Hi everyone, welcome to my video. Today we're going to look at GCSE Edexcel Maths higher tier paper, and we're going to be looking at the June 2014 paper. At first, the non-calculator one, then I'll do the calculator one. There's your formula page. Okay, first page is some fractions. Now, people worry about fractions because they don't know what to do when it's plus, minus, divide, take away. Okay, you do need to learn the 4 different things to do. I remember multiply is the easiest one. That's why you only get 1 mark for it. 1 times 2 is 2. 7 times 3 is 21. So your answer is 2 over 21. Part B, a takeaway is harder, is 2 marks, okay? So you need a bit of extra work. I've done a whole video on this. It's called the smiley face method, okay? What we do is we draw a smiley face. It's one of those smiley faces like this. There's the eyes, okay? And for each line you multiply. One of my subscribers calls this the X factor method to help them remember to multiply. 3 times 3 is 9. There's a takeaway in the middle. Okay, 5 times 1 is 5. 5 times 3 is 15. So it's going to be 4 over 15 as your answer. Okay, 3 marks in the bag. Question 2. Let me clear the ink off that last page. Stem and leaf diagram time. Okay, now the reason it leaves a little space for you is so that you can do a rough working out to make sure that you do not miss any values here. You look at your smallest value, which I can see is 5, which means there's 0 tens and 5 units. Okay. You then think, well, we go through the 1s, we go through 2s, 3s, 4s, and the 10s. Any 5s? I don't think so. Okay, so this is going to be our unordered stem and leaf diagram. Already ticked that one off, where we just make sure that we get all the values. So 13, 21, 19, 27, 31, 5 is done, 23, 29, 18, you're getting a bit of a rhythm with this, 25, 34, 15, 28, 23, 22, 40, 16, 19, 32, 32, and 9 on its own. Okay, now the ordered one, you still have the same tens, but you need to put these numbers in order. Okay, 3, 5 and 9 are already in order. 3 comes first here. Okay, you can tick these ones off too. 3, 5, 6, 8, 9, 9. Next one, 2, 1 is the smallest. 2, 3, 3, 5, 7, 8, 9, 1, 2, 4, 0 on its own. Okay, there's a key at the bottom here. I'll just do it on the side so you can see it clearly. The key is so that someone, if they didn't have these numbers, can look at your chart and know what each number means. So they need to know, if I'm looking at 1, 3, what does that mean? That means the 1 and the line and the 3 is 13. Okay, remember we got it from 13, that was our first number as it happens. Okay, that's question 2 done. Let me clear the ink. Question 3, wordy question. 50 people did one activity at a sports centre. Some people went swimming, some people played squash, the rest went to the gym. 21 of these people were female. 6 of the 8 people who played squash were male. 18 of the people used the gym. 9 males went swimming. What a lot of information. Work out the number of females who used the gym. Okay, so some people went swimming. Not sure how many. Some people played squash. Some people, the rest of them, went to gym. 9 males went swimming, so 9 males. 18 of the people used the gym. 18 people, okay? 6 of the 8 people who played squash were male, so that means that you have 6 male, 2 female playing squash. 21 of the people were female. Right, do we know how many people in total? Here's our strategy. 50 people in total, okay? So, do we know how many females in total? 21 of the people were female, okay? So that means that minus 21 to get the fact that 29 males. I'm just writing M for short for males. Don't worry, I'm not doing any complicated algebra there. We've already accounted for 9 out of 6, 15 males. So that means that the other 14 males must have gone to the gym. Okay? And that means because there's 18 people in the gym, 4 females must have gone to a gym. Okay? So 4 females is the answer. There's other ways around that question. That was how I would do that. That is for 4 marks. Not too bad at all. Mr. Brown has 2 children and they're going to London by train. An adult ticket is £24. A child ticket is £12. Mr. Brown has a family rail card. What a classic. Family rail card gives 1/3 off adult tickets, 60% off child tickets. Work out the total cost of the tickets when he uses his rail card. So, it's 1 adult, 2 children. Okay. So the 1 adult, it would have been £24, 24, but he gets 1/3 off. Okay. So, 1/3 of 24, if you know your times tables, you should know that 3 times 8 is 24. Okay, aka 28 divided by 3 is 8. So you want to knock off the 1/3, so you get left with 16 quid to pay using the rail card. 2 children, okay, so a child ticket is £12 each. So they would have been paying 12 times 2, which is 24 again. Okay, 12 times 2 is 24. However, they get 60% off. So what I would do if I was you is I would find 60% by saying 100% is 24. 50% is half of it, is 12. 10% you can divide by 10 from 100 and get £2.40. Okay, remember that was £12. Add those two together, that is going to give you that 60% is £14.40. So this is going to cost Mr. Brown for his 2 kids £14.40. Don't forget he's got to pay for himself. So you add those two together. Okay, I'll show you in the columns. £16, £14.40. So the total is going to be 4, carry the 1, £30.40. Okay, that's your total price. What a good discount. Always check the question you've answered. Work out the total cost of the tickets. Yeah, it doesn't ask us to compare to what it could have been. 4 marks again. Rebecca wants to find out how many books people buy. She's going to use a questionnaire. Oh, this one is important to get right. So, her aim is how many books people buy. So you're going to be asking, how many books do you buy? But this isn't good enough on its own. Okay, because imagine you're asking someone that and they're like, what do you mean? I can't answer. I don't know what time period you're talking about. How many books do I buy a day? a week, a year, they're all going to be different answers. So how many books do you buy? You can make it up. I'm going to say each month. Okay, that bit in green will lose your mark if you don't put it. Now it's a questionnaire. So what you're going to do is give them options. Okay, tick boxes. First tick box, I would say for people who don't buy any. Okay, the next tick box I would give for people who buy 1 to 5. The next one, you do not want to include 5 again. The people who buy 5 have already got a box to tick. So start on 6. I'd go 6 to 10. I'd probably give one for people who buy 11 to 15. And then people who really love their books, you need to give them an option too. You can't just think, well, I would never buy more than 15, so let's leave it there. Some people might, so just give them the option. 16 plus, okay? This survey question makes sure that everyone can answer it here. People who don't buy any, the people who buy 0 to 1 to 5, etc., and the people who buy loads of books. Even if they bought 1 million because they were a shop, they could answer that. Anyway, clearing. Bit of algebra, this is more like it. Expand. So this is my half a banana method. 2m times m is 2m squared. 2m times by 3, or 2 times 3 is 6, and it's 6m with a plus in the middle. Okay, so that's your answer. Factorize fully. Factorize is going backwards, so we've just got rid of the brackets. Factorize is go back into the brackets. Okay, so it's giving you a bit of a warm-up. We look at what is common in all of those, in those two terms. So I'm going to look at the letters first. X is common in both. Okay, this one you've got y squared, which means y times y. And in this one you've just got y. So one of the y's is common that you can take out. Now think of your numbers as well. You have to think, are your numbers in the same times table? 3 and 6 are in the same times table. They're in the 3 times table. So you can take that number out. Be careful, because this number in the times table has to be the biggest times table that both the numbers are in, which is 3. Now, you've got 3xy, and it's a little times like we did before. And you want to think, if you did your half a banana, what would have to be here so that you got 3xy squared, which means 3xy, y. Okay? And the answer is, you would only need an extra y to get this combination. Next part, what would you have to multiply 3xy by to get 6xy? The answer is you just times it by 2. And then an important thing not to forget is there's a negative in the middle. Okay, so that is your answer. Let's clear the ink off. Question 7. It's a starred question, so there's going to be a little bit of explaining to do here. Right, the diagram shows the plan of a small field. Okay, Kevin is going to keep some pigs in the field. Each pig needs an area of 36 square meters. Okay, work out the greatest number of pigs Kevin can keep in the field. What a dilemma. Okay, so he needs to think about his pigs. He doesn't want them to be all squashed together. He wants them to have enough space. And he knows that each one is going to want 36 square meters of space. So what Kevin wants to do is figure out, well, how much space have I got? So that I can figure out how many pigs I can fit in. Now what you want to do that is you want to split this shape up. Okay? You don't know how to find the area of that weird L shape straight off. Okay? So what you have to do is you have to split it into things you know how to find. I hope you're shouting at the screen. Make it into 2 rectangles. Maybe in your head you did it like this. Okay? Doesn't matter. Both ways will work. But you only have to pick one. I'm going to go for that one. So we've got one blue rectangle there, one red rectangle here. Okay? and we're going to find the area of each and add them together. The blue one's easy. It's 7 by 10. To find the area of a rectangle, 7 times 10 is 70. The red one is more tricky. Do not make the mistake of thinking that this top length here is 16. It's not. 16 is all the way. So you need to figure out how to find that missing length. Now, can you see that this length here is the same as the length at the top? So we need to know what you have to have here to make 16 in total. Well, you've got 7, you need to plus 9 to get the 16. So it's 9 by 6. To get the area for the red one, 9 times 6 is 54. Okay, so your total area equals, always do the adding up in columns, 70 plus 54 is going to be, why did I do that? Carry the 1, 124. Okay, so area equals 124. Now we have to see how many 36s go into it. No pig is going to want less than 36 square meters. They've got high standards here. So let's see. That's one pig, 36. Add another pig. Okay, add 36 again. That's going to give you 72. What am I writing that for? 72. Okay, you're just doubling it effectively. So that's 2 pigs, 36, 72. Add another 36 on to give you how many 3 pigs would need. So it's going to be 801, 108. Add another 36 to see if you can add another pig on. Okay, if you add these two, you're going to get too much, 144. So you're in the red then. Yes, we can fit 1, we can fit 2, we can fit 3. We cannot fit 4. We only have 124. Now I know you're wasting a bit of space, but sometimes that happens in life. Okay, so the answer is Kevin can only have 3 pigs. Okay, Kevin can have 3 pigs. I guess it's better than none, but it's hardly a massive achievement. 3 pigs, is it? Hardly going to be farmer of the year. Okay, question 8. So we've got a diagram showing a garden in the shape of a rectangle. We've got the scale of the diagram as 1 centimetre represents 2 meters. That information is so important, it has told you that information twice. So let's write it down one more time. 2 meters, 1 centimetre. Okay. If Anne is going to plant a tree in the garden, the tree must be more than 3 meters from a patio, and here's the patio, okay, and more than 6 meters from the center of a pond. Here is the center of a pond. On the diagram, shade the region where Irfan can plant the tree. Now I'm afraid this is going to be difficult for me to do on the video because I can't use a ruler or a compass as such, but I'm going to show you the exact technique of what to do. So the first bit of information, we're going to do this in blue. Okay, more than 3 meters from the patio. So we need to know how much 3 meters is. Now if 2 meters is 1 centimeter, 1 meter you're going to get by halving it, half a centimeter. So 3 meters is going to be 1.5 centimeters. So you're going to get your ruler, you're going to measure 1.5 centimeters here, you're going to measure 1.5 centimeters here. Then you're going to get your ruler, you're going to draw a perfectly straight line. Just pretend. Now we want it to be more than 3 away from a patio, so we want to aim this direction away. Okay. Next bit of information I'm going to do in green. 6 meters from the center of the pond. Center of the pond is here. You want it every single point that is 6 meters away. Now if we think of how much 6 meters is, it's going to be 3 centimeters. You can think of 3 times this, or you can think of 2 times this. Both work out the same. Okay, so 3 centimeters away, you get your ruler, you could measure 3 centimeters, but that's just one possible point. You could keep doing that with these lines. The shape you actually get is a circle, which is why I mentioned the compass. You measure your compass, imagine that's your compass, 3 centimeter gap. Okay, you stick it in the middle here and you draw a circle 3 centimeters wide. We don't need to go outside the garden, okay, because we can't plant it there anyway. It has to be more than that, so you want the part that is away. And you shade in all the area that applies, and this red bit that I've shaded here is where you could plant the tree. That is for 3 marks, okay? It's called a loci question. So let's clear that off. Question 9. Part A. On the grid, rotate the shape A 180 degrees around point 1, 1. Okay, so let's highlight point 1, 1. 1 across, 1 up. That is point 1, 1. We want to rotate it around. Imagine that you've got this stick that's holding your shape. We are rotating the stick 180 degrees. Okay, so we're actually, if you imagine, going to turn the stick round to here. If you don't like my stick way, you can use tracing paper. It will do the same job. And on your tracing paper, you can use the shape, and you can think, we're spinning it. Can I spin this shape? Rotate? Afraid not. Sometimes I can. What's actually going to happen is half a turn, 90 degrees, okay, quarter of a turn really, is going to make this shape come around and around until this right angle becomes here, like that. Okay, if we spin it around again, it's going to be coming this way. Okay, this right angle is going to be here in the corner. Okay, and that shape has been rotated 180 degrees. Okay, half a turn. 360 is a full turn, 180 is half a turn. Okay, so now we need to put where the stick is going to be at the end of our, where the shape is going to be at the end of our stick. So it's going to be attached here, and I'm trying to draw the opposite. It's going to go like that. One here. It's here. Your tracing paper would make this much easier. I'm a bit disappointed that I couldn't spin it on the board. I'm sure I've done that before. Well, okay. Rotate it around, job done. That is our new shape. Sometimes it tells you what to label your shape, but it's not in this case, okay? That's our new shape. Okay, 2 marks. Clear ink. Part B. On the grid, enlarge the triangle B by a scale factor of 3 with centre 0, 0. That is 0, 0. This is the shape that we're going to enlarge, triangle. We need to put where those 3 points are going to go once you've enlarged the shape. Let's do this bottom point first. You have to say from across, how do you get to that bottom point? So you go 1, 2, 3 across and 1 up. Now you're enlarging it with a scale factor of 3. So anything that you did before, you need to do 3 times that. So instead of going 3 across for our new shape, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 3 times 3. So you've got 9 across. Instead of 1 up, times by 3, 1, 2, 3. So this old corner has gone to here now. Okay, what I would recommend you do after you've done the first step is cheat. This is 2 across. If the shape gets 3 times bigger, every single length getting 3 times bigger, then that's going to go to 6. So you know it's going to go 1, 2, 3, 4, 5, 6. This old one was 1 across. It's going to be times 3 times bigger. That's going to go to 3. Now you know it's a triangle, so you know that you can just join that up. That's why I said it's kind of cheating, because we're just joining it. Okay, the straighter ones that aren't diagonal are easier to do. Now to check, you would do all this with a ruler, by the way. Don't think I'm trying to condone that you do it freehand like I am in your exam. I would never do that. From the origin, we go through the corner, we carry on with a ruler, tick, it's gone through. Try the next one. Carry on with our ruler. Yeah, if I'd have done it straight, it's gone through. Next one, these are called your projection lines, by the way. Carry on with your ruler, tick, it's gone through. So you know that you've enlarged the shape and you've got all of your marks, which is 2 marks, okay? If you don't put this in the right place, you just make it bigger, you only get 1 of the marks, I'm afraid. It has to be in the right place there. Okay, clearing. Question 10. It's a comparison question. Milk is sold in 2 sizes of bottles. We can get 4 pints for £1.18, or we can get 6 pints for £1.74. Excuse me. Okay, we want to know what's better value. Better value means you don't care how much milk you're going home with, you just care about how much you paid per bit of milk. You want to pay the cheapest. So one way we can do this is a little bit like the simultaneous equations question, but if you don't know what I mean, don't confuse yourselves. The lowest common multiple of 4 and 6, basically, what is in the 4 and 6 times table? And the answer is 12. So that means that we can compare 12 pints. Okay? So I'm going to move all this across, and we're going to work out how much 12 pints is going to be. For the 4, we need to times by 3 to get 12. For the 6, we times by 2. Okay? So 12 pints, we're going to be doing times 3. So it's 118 plus 118 plus 118. Okay, 8, 16, 24, over 2, 5, £3.54 for 12 pints. You might not want 12 pints, but that's not what value means. Okay, we're not even considering how much you actually want. Asda's quite good because it tells you underneath prices how much you're getting per unit. So it might say, next to some milk, what's the effective cost per pint, for example. Have a look out for that next time you're shopping. If we want 12 pints and we know how much 6 are, we just double it. So let's do a bit of working out down here. Double £1.74, 8, 4, carry the 1, £3.48. So now we think about which one is cheaper. Okay, and we can say, so 4 pints is more expensive. We want to write which one's cheaper. So 6 pints is, you can even show off and say that's a difference of 6p for 12 pints. But you can just say 6 pints is better value. Okay. Right, moving on. Let's clear that off to question 11. ABCDE is a regular pentagon. BCF and EDF are straight lines, as we can see. Work out the size of the angle CFD, so from C to F to D, that's this angle. Okay, let's call it X. You must show how you got your answer. Okay, now this shape here is a regular pentagon, as we're told in the question. So it's got 5 sides, it's got 5 angles, okay, and they're equal angles. Now these are called the interior angles. The ones that we're actually interested in are the ones on the outside here. Okay, and they're actually going to be the same. So if we know one, we know what they both are. Looking at the point around the angle C, I actually did a video explaining why if you go around the edge of a shape, okay, the exterior angles here are all going to go and add up to 360. Okay, it's to do with turning around, and if you come back to where you started from, you've turned around a full circle 360 degrees. It's quite a weird video that I did with an ant walking around a shape, but there you go. Hopefully it does the job. Okay, so that means if there's 5 of these angles and they're all the same, okay, then they add up to 360. So 5 times, let's call this angle y. 5 times y equals 360. Okay, if you don't want to use the algebra, just think what goes into 365 times. If you don't know 360 divided by 5, you can do the bus stop method. 360, 5, 5's into 3, 0. 5's into 36 is 7. Carry the 1, 5's into 10 is 2. Okay, so these angles are 72 degrees each. Now we also know that angles in a triangle add up to 180 degrees. Okay, so angles in triangle add up to 180 degrees. So that means that 2 times 72 plus x equals 180. Okay, 2 times 72, you can just double it. This is how I always double in a non-calculator paper. Okay, for 144. So 144 plus something gives you 180, which you can get by doing 180 take away 144. Okay, so 0 take away 4 you can't do, borrow 1. 10 take away 4, 6. 7 take away 4, 3. So the answer is 36 degrees. Okay, angle CFD equals 36 degrees. That's your answer. Okay. It's not got a star next to a question, which is why I didn't go to too much detail. Okay. However, I did show the working out, which is what it asked for. Question 12. You can change temperatures from degrees Fahrenheit to degrees C by using the formula C equals 5 times brackets F minus 32 all divided by 9. Okay, so F is standing for degrees Fahrenheit and C degrees Celsius. The minimum temperature in an elderly person's home should be 20 degrees C. Mrs. Smith is an elderly person. The temperature in Mrs. Smith's home is 77 degrees Fahrenheit. So let me guess, we're going to have to convert and see if it's bigger or smaller. Part A, decide whether or not the temperature in Mrs. Smith's home is lower than the minimum. So we need to convert 77 degrees Fahrenheit to degrees C. Okay, and we've got the formula to do that, which is here. So let's write the formula again. C equals 5 F minus 32 all divided by 9. Okay, so C equals 5 times your number, which is 77, minus 32 divided by 9. We can work out the maths here. This is your BODMAS rules. You have to do what's inside the bracket first. 77 minus 32 is going to be 45. Okay, and it's 5 times 45 divided by 9. They've been quite clever by putting this on the calculator paper because there's a shortcut. Some people, most people, would do 5 times 45 and then try and divide by 9. Okay? I'm not going to do that because I've noticed that 45 is in the 9 times table. Okay? So I'm going to do a shortcut. I'm going to write the top row as 5 times 5 times 9. Okay, and we're dividing all that by 9. The reason I've done that is so that we've got a times 9 on the top and divide 9 on the bottom, so they cancel out, and 5 times 5 is 25. Okay, so the temp is 25 degrees C. We're saying it should be at least 20. It's greater than 20. Decide whether or not the temperature is lower. So therefore, that sign is therefore not lower than 20. Temp is okay. And that's 3 marks there. You have to give your reason to come to the right conclusion. Okay, let's clear that ink. Part B. We have to rearrange and make F the subject of that formula. So we've got some quite tricky algebra here. You have to know how to undo everything on this side to get a final result with F equals. And it usually gives you a clue here, but it's been quite nasty and it hasn't done that. No problem there. Let's try and get F on its own. There's 3 things that we've got to undo, and if we don't undo them in the right order, we're going to mess up the equation. Okay? Can you see this divide by 9 is doing it to everything? So that's the first thing that we're going to try and get rid of. We're going to get rid of a divide by 9 by doing the opposite. We're going to times by 9. Okay? So 9 times C is 9C. We've got rid of this divide by 9. So all we're left with is the top row. Okay? Remember, this is a little multiply next to brackets. So what we need to do is get rid of next the times 5, because the times 5 is doing it to everything. Okay? We can't get rid of this minus 32 yet. It's nested inside the bracket. So let's divide by 5. Okay. Now, a little cheat on your exam is to write, when you can't do a division very easily, write as a fraction. Okay, like that. That means divided by 5, doesn't it? So that's fine. Now we're left with just a bracket. We don't need to write the bracket anymore. Okay, so what we can do now is get rid of the last thing. Can you see it's separated now? It's free. It's on its own. So we can undo that by adding 32. Add 32. So on the left-hand side, you get 9C over 5. Add 32 equals F. That's a bit of a weird way around to write it. All we're going to do is write it the other way around. Okay? So 9C over 5 plus 32. Job done for 3 marks. Nice bit of algebra if you like algebra. If not, you might have to watch that a couple of times. Right, we've got a competition. In a competition, a prize is won every 2014 seconds for a lucky winner. Okay? So, work out an estimate for the number of prizes won in 24 hours. Show all your working. Key word in this question, I'm going to get the highlighter pen, it's that important, is estimate. Okay? You need to estimate. You cannot work this out quickly if you work it out exactly. Okay? So let's think about the question. The question is basically giving something in hours and something in seconds. So if we've got 1 minute, that's 60 seconds. Okay? If we've got 1 hour, that is 60 mins. Okay? So that means that if you want the time in seconds, 1 hour is going to be, because for every minute there's 60 seconds, and there's 60 minutes, 60 times 60. Okay? So 6 times 6 is 36, and 0, 0. Okay. Now we've got 24 hours. So for 24 hours, I'm not going to rush ahead and do the calculation. 3600 times by 24. Okay, and we want to know how many lots of 2014 go into that. And it's an estimate. Let's write out the actual calculation. It would be 3,600, which is the amount of seconds per hour, times by 24 hours, because that's how many we've got, divided by 2014 seconds. If you've practiced a lot of past papers, you might know, as I do, that sometimes it just gives you a question like that and says estimate. This question is much harder because you have to go from words to that equation yourself. Okay? Now, because it's an estimate, all estimate means is make your life easy. Okay? Make your life easy, which is a good life tip. Right, so how are we going to make our life easy? Well, things would be easier if we just round to one significant figure for each number. So that's what we're going to do. We're going to make it a nice, easy estimate. So, one significant figure, 3,600, is going to round up to 4,000 because the 6 rounds up. Okay, 24 is going to round to 20. 2014, 2,000. So we've made this as simple as possible. On the top, let's multiply. 4 times 2, 8, and you can count your zeros. Okay, 4 zeros. And on the bottom, 2,000. Okay, now, because we're timesing on the top, dividing on the bottom, and every 0 means that what we're doing is timesing by 10, okay, we can cancel these, because that's times 10 divided by 10, times 10 divided by 10, times 10 divided by 10. Okay, so 80 over 2, and our estimate is 40 prizes won. 40 lucky people in 24 hours. I just wonder what they're going to win, that's all. Okay, hope that made sense. We've shown all our working out. If you really want, you could have used that as 25 and got away with it. But, like I said, I would advise, make your life easy. That was 4 marks. Emily's driving in France. She sees this sign. Emily's going to drive to Dijon. She plans to drive at an average speed of 50 miles per hour. Work out how long it should take Emily to drive there. Okay, so 50 miles per hour. And let's look at the sign to see how far Dijon is away from Emily. 480 kilometers. Oh dear, that is a nasty question. You need to know, and you actually have to learn this, that 1.6 kilometers equals about 1 mile. Okay? And that is a tricky question because it hasn't told you that. And if you do not convert so that your units are the same, you're going to get this wrong. So this 2014 paper is trickier, I'm not going to lie. Things like this are cropping up. So, let's get down to the job at hand. First thing that we're going to do is we're going to convert 480 kilometers to miles. Now, luckily, I've noticed, because I actually think that 16 and 48 have common factors. Okay? Think about adding up 16. 16s. Okay? 16, 32, 48. Can you see where I'm coming from? This question has been set up for you so that the numbers work. We'll come back to that. 116, 2 times 16, 3 times 16. So, 1.6 kilometer, 1 mile. Okay. We want to know 480 kilometers. Okay. Before we do that, all I'm going to do is times by 3 let's move that down a bit. I'm going to times by 3, and because 16 times 3 is 48, 1.6 times 3 is 4.8. So 4.8 kilometers, 3 miles. Okay. Now we can see that the next times by 100. Okay. To move your 4 from the units to the hundreds. So that sign is basically saying 300 miles away. Okay. And we are traveling at 50 miles every hour. So let's imagine our journey. Go along. Okay. This is just for illustration purposes. It's not going to be accurate. If you've gone 50 miles, it's taken you 1 hour. Okay. If you've been driving for 2 hours at the same speed, you've gone 100 miles. Okay, which is 2 times that. So if every hour, 50 miles per every hour, that means that we can do 300, which is how far we've gone, divided by 50, okay, to see how many hours it's going to take us. So that comes from a formula, speed equals distance over time, and just rearranging to get distance equals speed times time. Okay, so 300 divided by 50, cancel those out. 30 divided by 5 is 6. So it's going to take 6 hours is your answer. Okay, that was hard. 4 marks for that. Moving on. Question 15. Complete the table of values for x squared minus 2x minus 1. Okay, and this x value we put in depending on what the value of x is here. Okay, and in theory you can put in any possible value number you can think of into this equation for x each time. Now my cheat for this question is to look at which ones are easier. It's easier to put 4 into the equation than minus 1. So I'm actually going to start here. And what we're going to do is where it's x, put 4 instead. It's called a substitution question. 4 squared minus 2. Okay, when it says 2x, that's 2 times x. There's a little multiply there that we do not write. Okay, so 2 times 4, and then at the end, minus 1. Okay, 4 squared is 16. 2 times 4 is 8, and it's a take away, and then a minus 1 at the end. When I'm saying minus and take away, they mean the same thing. Okay, so 16 take away 8 is 8. Take away another 1, leaves you with 7. So your answer for 4 is y equals 7. The next one, we're going to do the exact same thing, but instead of putting in x as 4, we're going to change x to 3. So just erase the 4, we're going to put 3 instead. And it's times, remember. 3 squared, 3 times 3 is 9. 2 times 3 is 6. Take away 1. So 9, take away 6 is 3. Take away another 1 is 2. Okay, 0 is a nice easy one to put in. Because what's 0 squared? That means 0 times 0. Okay. 0 times 0 is just 0. And 2 times 0 is just 0. So you can ignore these. Your answer is just minus 1. And because I've cheated, I already know what the next answer is going to be. Okay, can you see the pattern? Minus 2, then it goes minus 1, then it goes 2 there, 7, 7. Guess what this is going to be? It's going to be 2. Just so you think I'm not cheating too much, I'll show you the working out for that as well. Okay, it's always worth checking, and you should probably use that cheat just to check you've got the right number there. If you break the pattern, then something's gone wrong. So, this is because it's x squared that it repeats. So minus 1 is going to go here, and we need brackets to keep the minus 1 together. Okay? So this one's harder. Minus 1 times minus 1, and minus times a minus gives us a plus. So it's plus 1. 2 times 1 would have been 2, but you've got a minus times a minus again, so it's plus 2. Take away 1. Okay? 1 take away 1 is going to disappear, so like I predicted, the answer's 2, but at least I've shown you now. Don't have to feel guilty. Right, let's plot this onto the graph. So x is your horizontal axis, there's x. Y is your vertical axis, so you plot these as coordinates. Okay, so minus 2, 7. Across to minus 2, up to 7. X comes first in the alphabet, so X along the corridor before you go up the stairs, you might have heard before. Next one, minus 1, 2. So you go across to minus 1 and up to 2. Next one, 0, minus 1. 0 across, 1 down. 1 across, minus 2, which is 2 down. Now, because it's a quadratic graph, which is something to do with x squared, it's going to be that shape. So this is what I was talking about. It's going to repeat. 2 across, 1 down. 3 across, 2 up. And 4 across, 7 up. Right, this is where you've got to be careful. Get your art skills ready. And get ready to draw a smooth curve through all those points. Okay? Take 1. Let's have a go. Could have been better. Could have been much better. Let's try and cheat a bit. There you go. With your pencil, just be very careful. I used to put my elbow here, turn the page around, draw around that way. Okay, but just whatever suits you. It's got to be a nice smooth curve that passes through all the points. With a bit of practice, you'll get it sussed. Oh, shouldn't have deleted that because it's saying solve this. Okay, and there's a trick to do it. Because we've just drawn that graph, I'm going to have to sketch it in again. Y equals x plus 3. Okay. I'm just reminding myself what I'm going to do. I need that graph again that I've just deleted. So let me quickly draw it. It was there. What was the other point? 2, wasn't it? 2. Hope I don't go wrong on this. I think it was that. Shout at the screen if I'm wrong, but I think that's right. At A level, if you do go into A level maths, you just get told that and you get told to sketch it. Okay? If you plot points at A level, you actually, unfortunately, do not get the marks like you would at GCSE. Right, that's a really dodgy. That's going to have to do, I'm afraid, because I want to focus on the next question. We've already done this. So, what the next question said was solve x squared minus 2x minus 1 equals x plus 3. Now, you could solve this with algebra, but the reason it's only 2 marks instead of more is because you can, is it 2 marks? I might be lying to you there. Yeah, 2 marks. Is because you can do it a different way by using the graph. Okay? So what do I mean by that? Can you see, can you spot that that's what we've just drawn? That is the blue line. Okay? So what we can actually do, we've drawn y equals x squared minus 2x minus 1. We can think, well, the only thing we've not drawn that's on here is the x add 3. So we can draw the line y equals x add 3. Okay? Think of y equals mx plus c. It's got a gradient of 1. It crosses the axis at 3. Okay? Let's think about what the gradient of 1 means, because the scale is a bit dodgy. So it means it's going to be crossing here. Okay? And it's going to be going 1 up, 1 across. It looks like it's going more across because the scale's different. That's one across, and that's one up. That's why it's a bit dodgy. Okay, and there. So you can already probably see what I'm going to do next. Going to draw that line in. So what's it mean solve? Well, the red line is every single answer possible, so that something equals x add 3 on. Okay? The blue line is every single possible answer, the something squared, take away 2 times it, take away 1. Now where your lines cross, that means it solves both at the same time. Okay, these are called points of intersection. Now when it says solve, can you see any y's in this equation? It's only got x's, so you only actually need the x values. Okay, so x is minus 1 or x equals 4. If you don't believe me, then you can try the algebra yourself. You would have to take this to this side and factorize, which is a bit longer, or just to test out what I've said, you could try and substitute in 4 to both sides and see what you get. On this side you get 4 add 3 is 7. On this side, well, we've already said you got 7 because we did it in the table. So they're the same. Equals means the same. That's what they are. Okay. Question 16. Colin took a sample of 80 football players. He recorded the total distance in kilometres each player ran in the first half of their match on Saturday. Colin drew this box plot for the results. Okay. Work out the interquartile range. Now the interquartile range means you get your lower quartile and your upper quartile, and you take your lower one from your upper one. IQR. Okay. So what do I mean by these quartiles? Well, box plot splits your data up. How much data? Not evenly. Well, the data is split evenly, but it might be more spread out in certain places than others. Okay. This is a quarter of the data, a quarter of data, a quarter of data, quarter of the data. Okay, interquartile range. Here's the upper quarter, the upper quartile. Okay, let's just check our scale. So imagine if it was just guess at first, guess it was 0.1, 4.1, 4.2, 4.3, 4.4, 4.5. So each dot isn't 4.1. Let's try 2 dots as 4.1. 4.1, 4.2, 4.3, 4.4, 4.5. So you've cracked it. Okay, so that means that when we've gone from 5.5, 2 squares across, that's an extra 0.1, so 5.6. Here, below, you've gone an extra 4.5, 4.6, 4.7, 4.8. Wow, 4.85. Okay, really getting tricky with these numbers. So you have to do that takeaway. So when we do a takeaway in columns, we need the same number in each number. Okay, the same number of digits. So we add the 0 there, and we're doing a takeaway. 0 take 5, you need to borrow. 10 take 5 is 5. Okay, 5 take away 8, you need to borrow again. 15 take 8 gives you 7. Decimal point stays the same. 0.75 is your answer. Okay. There were 80 players in Colin's sample. Work out the number of players who ran a distance of more than 5.6. We've just said that this is 5.6. Okay. And I was explaining about splitting it into quarters. This is 1 quarter, aka 25%. There were 80 players in total. Okay, so you want 1 quarter of 80. So 80 divided by 4. Okay, well 8 divided by 4 is 2. So 80 divided by 4 is 20. Okay. Colin also recorded the total distance each player ran the second half of their matches. He drew a box plot for this information. Compare the distribution, so distance ran in the first half with the distribution for the second half. So we want to be able to see both box plots in the same screen, okay? And I can actually probably cheat a bit with this by using this software. I can actually put them onto the same diagram by being a little bit clever, not too clever. I'm going to draw over this, okay? I'm afraid you would have to, you can't move your page around the same way, you would just have to compare normally. But now we've got them on the exact same diagram, which is really cool, and that's really what the examiner wants you to be thinking about. How do they compare, how are they different, how are they the same? It's 2 marks, so you need at least 2 things. When you compare these box plots, what you want to compare is an average and about how spread out they are. Okay? So an average, 4.5, 4.6, 4.7, 4.75, okay, is the median. Okay, it's the middle. So second half, median equals 4.75. First half, median equals the green one, 5.1, 5.2, 5.3. Okay, kilometers, remember. So the first thing that we can say, on average, using the median, the players ran more in the first half. Okay, so what we're basically saying is first half median is higher. Okay, second thing we need to compare is how spread out they are. We already got the interquartile range before. I think we got 0.75. Okay, unless I've got a terrible memory. So first half IQR equals 0.75. Okay, so we want the IQR for the second one. So we can actually count this 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.75. Look at that. Okay, that's very cool. However, the IQR is the same. So that means the spread of the data is the same. Okay? The spread is very similar or the same in both. Okay, hope that makes sense. Don't have to be perfect sentences in maths, and you've just got to get your point across in these questions. Question 17. Write down the value of 10 to the power of 0. Okay. So basically, this comes from your power laws. So I think I'll just show you very quickly. Any number divided by itself is 1. Okay. Any number divided by itself is 1. So any number on its own has a power of 1 times by itself once. If we use your power laws, which hopefully you know on this, it's a divide, so you do a take away. This power, take this power. So that means that any number to the power of 0 is 1, okay, because these are the same. So, long way for me to explain. When it tells you 927 to the power of 0, your answer is 1. When it tells you 5.48 to the power of 0, your answer is 1. Okay, also another thing that gets used a lot at A level. Write down the value of 10 to the minus 2. Okay, when you've got a minus in the power, what you actually do, again due to the power laws, okay, because you could think of it as 0 take away 2, your 0 power being on the top, giving you the 1 on the top, and the 2 power being on the bottom, giving you 10 squared, okay? So 1 over 100 is your answer there. Part C. Write these numbers in order of size. Start with the smallest number. So, let's have a quick look. 10 to the power of 3. So that means that you're going to make your number 10 times bigger, and you're going to shift it to the left 3 times. Okay? So let's keep the decimal point there, and let's go 1, 2, 3. Okay? So the 2 goes here, and we move the 7 to the next one, 3 to the next one. We've got a gap here for a 0, and we do not need the point there. That number is just 2730. Next one, 10 to minus 3. That is going to move this way by 3. Okay, so we started off with 27.3. We're going to go 1, 2, 3. Okay, so our 2 is going to go here. The 7 goes one beyond. The 3 goes one beyond. Decimal point stays the same. Fill in your zeros. Quite a small number. Next one, this one is going to be getting bigger. Okay, timesing by 10 twice. So that moves it to the left twice. You can actually just add 2 zeros there. Okay, so let's compare order of size now. Smallest, okay, let's be good and let's write it how it gave it us in the question, because someone did make that comment on a previous video that I've made. Okay, it is the best way to do it. The smallest is 0.00 something. Okay, so that's our first one. Next number, smallest, is 0.0 something. Okay, the next smallest is this one. And the next smallest, okay, am I saying smallest, do I mean biggest? You know what I mean. You know what I'm like by now. So, in order, first one, number 1. Next one, number 2. Next one, number 3. Next one, number 4. And I've wrote them how they are in the question. Okay. Right. Question 18, a nice pair of simultaneous equations. Now I've done a whole video on simultaneous equations explaining my method. I can't explain it in too much detail now, but if you don't follow what I'm doing, check that one out. This at the front, next to x, is a 1. There's no numbers lined up with the same coefficient of the letters. That means there's no numbers in front of the letter that are the same. So we need a step that I call step x. That means that we're multiplying, okay? We multiply by the opposite. So up here we multiply by 1. Down here we multiply by 4. Okay? Multiplying by 1 doesn't actually change anything. So our top equation stays the same. Multiplying by 4 does change things. We need to do it to every single term. 1x times 4 is 4x. 3y times 4 is 12y, and it's a takeaway. 16 times 4, you might want to do a bit of working out. Double it, 32. Double it again, 64. Okay, times by 4, double, double. Now there are simultaneous equations. There is an extra step that you can actually do here if you want, which is a switcheroo. You can literally just swap the two equations around. Write the bigger one at the top and the small one below. Then you can carry on with your day and your method that you were doing. Rectangle is my step 1. If you see my video, you'll know what I mean. The signs are the same in the front of both. They're both plus. So stop. Same sign, it's going to be a takeaway. This means opposite sign plus, by the way, but we've got the same sign in our rectangle. So we take away 4x, take away 4x. You should always get 0 below your rectangle. Be careful at this bit. Minus 12y minus 1y. Okay, so you're already on minus 12 on your number line. And you go back again, so you're on minus 13. Okay. 64 take away 25. This is why I swapped around. Okay. They're making you do a lot of subtraction in this paper. 39. Okay. Think about your 13 times table. 13, 26, 39. Okay. Adding 13 each time. So 39 divided by 13 gives you 3. However, it's a negative 13, so you put minus 3. So we found one of our letters. We now go back to one of the original equations, the one that we think is easiest. We write it again, okay? And now we substitute what we found into here. We found out that y is minus 3. So instead of y here, we can actually have minus 3. So 4x minus 3 equals 25. Okay, and then we can just solve this as an equation on its own. We want x, so we want to get rid of the 3, get rid of the minus 3 by adding 3. 28, divide by 4. Okay, half it again. Half of 28 is 14, half of 14 is 7. So in your answer, there'll be, that's only 3 marks. There'll be a place for x is 7, and a place for y is minus 3. Okay, there are your 2 answers. Job done. Moving on. Question 19. The diagram shows a straight line L1 drawn on a grid. So here's L1. A straight line L2 is parallel to a straight line L1. So the information that we know is that whatever this line is, we have a line that's at a right angle to it. Okay, so I'm going to draw something on that's at a right angle. Okay, so L2 is at a right angle. The problem is we have no idea where it is. Okay, so this L2 could be anywhere, but that's how steep it is because it's at a right angle. It passes through the point 0, minus 5. Okay, so 0 across, minus 5 down. It's going to be down here somewhere. Okay, so a straight line is going to be around there, visually. Okay, find the equation of a straight line L2. So let's go for a bit of algebra. This equation, this green equation, is going to have the form y equals mx plus c. C stands for the intercept, which is where it crosses the y-axis. Now we've been told it goes through 0, minus 5. So it crosses the y-axis at minus 5. Okay, so that is minus 5. M is the gradient. So that is the y-intercept. And m is the gradient. Okay. Gradient is how steep it is. Now you could think about this visually on the graph and think, well, this one goes 2 across and 1 up originally, and the gradient you get by doing the change in y over the change in x. Okay, remember to get this the right way around. So in this case, the change in y is 1, the change in x is 2. So the gradient here equals a half. Now you might know something about perpendicular gradients, okay, but this is more A-level. For perpendicular gradients, the 2 gradients multiplied together give you minus 1. Okay, so if we want a gradient that's perpendicular to a half, what do we have to times it by to get minus 1? Well, the answer is you can just flip the fraction over and put a negative, minus 2 over 1, or just minus 2. Some people call this the negative reciprocal. But let's think about what's going on the graph. If it is at 90 degrees, like that, okay, then we can think of for changing y as minus 2, changing x as 1. So you get minus 2 either way, by looking at the diagram, or by just thinking about the algebra, which is this equation. Okay, either way, you get minus 2 here. So the equation of a straight line L2, y equals minus 2x minus 5. Okay, using this formula, y equals mx plus c. That's why it's so useful. Okay, and that was 3 marks. Question 20. Steve has a photo and a rectangular piece of card. The photo is 16 centimeters by 10 centimeters, as we can see. The card is 30 centimeters by 15 centimeters, as we can see. Steve cuts the card along the dotted line shown in the diagram below. So he wants to cut it up here, okay, with his scissors. Steve throws away the piece of card that is 15 centimeters by x. So he doesn't want this. We've all been in this situation where we want a nice frame around our picture and there's just too much in our rectangle. In real life, you guys might do that by guessing and just think, cut up here and make it look right. But if you're a mathematician like Steve, you want to do this properly, okay? So how's he going to do it properly? He's going to do it properly by making sure the piece of card is mathematically similar to the photo. Okay? That means if you've got your photo, then the card is going to be an enlargement of that photo. Okay? So, what we need to think is it's been bigger. Okay? So it's in the right proportion, really. So the gap around the side is going to be nice and fair. Anyway, let's do the maths question now and talk about cards and papers. So, let's think about what's happened. Our card here, our picture is 10, and it's going to change to 15. We want to keep this as 15 for certain. So we know that we're going from 10 to 15. And we want to do it with a scale factor, which means multiply. You can divide and multiply, that's up to you. To get from 10 to 15, don't say add 5, we're timesing or multiplying, because if you just added 5, then it wouldn't be mathematically similar if you just added 5 to 16. It's not the same effect as adding 5 to 10, because they're different starting numbers. Whereas if you multiply by a scale factor, it has the same effect of enlarging them by the same amount. So, to get from 10 to 15, we could do 10 divided by 2 and get to 5, and then times by 3. So divide by 2 times by 3 is our trick. Okay? And if you really want to be precise, dividing by 2 times by 3 is the same as timesing by 3 over 2 or 1.5. Okay? Depends how you see it. That's up to you. So, timesing by 1.5 or dividing by 2 timesing by 3, we're going to do the same thing from 16 and see what we get. Okay? So we're going to do 16. Let's do the original way. Divide by 2 gives you 8. Times by 3 gives you 24. So we've made it 1.5 times bigger. So this is going to be 24. Okay? Because not 30, 30 is too big. So it was 30. We want to get rid of a certain amount and get to 24. So 30 minus 24 gives us 6. So we want to cut 6 centimeters across, and that's how you get a perfect picture, guys, in a frame, if you ever want to know. Okay? To be fair, it is quite useful. So x equals 6 centimeters, or just 6 because the centimeters already there. Okay, that was 3 marks. Moving on, question 21. B, C, and D are points on the circumference of a circle. B, C, and D. Center O. A, B, E. Let's just look at that. A, B, E. Let me guess, a straight line. Okay. Tangents to the circle. Tangent means it touches it once. Okay. Exactly once. It doesn't cross it, just touches the edge of a circle. So, angle DAB equals 40 degrees. We can see that. Angle CBE is 75 degrees. We can see that. Work out the size of angle ODC. Okay, so from O to D to C, we want this angle. Let's name it X. Okay, right, so let's think about this. First thing I'm going to do is I'm going to say that tangents meet the circle at 90 degrees. That's one of the circle theorems. I have done a video on all of the circle theorems if you want to check that out. Okay, so that means it's 90 all the way, minus 75. This is 15 degrees. This is 90. This is 90. We can add an extra line in here. Okay, and then we can think about this as a triangle, a right-angled triangle. And it would help us if we find this angle here. Half of 40 is going to be 20 degrees. This is 90. Angles in a triangle add up to 180. So 20 and 90, we're on 110. 180 minus 110. Y is 70 degrees. Okay, so this angle here is 70 degrees. If we apply the same thing to this triangle, guess what? The angle is going to be 70 as well. Okay, so this is 70 here. And that means, sorry if this is getting a bit messy, but this whole angle here is 140 degrees. Another circle theorem says that angles in a shape like this, with a Star Trek sign, the one at the center is double the one at the circumference, which means that angle BCD is 70 degrees. This angle around the edge there is going to be 360, a full turn. There'll be other ways to do this, I know, but I'm just doing it spur of the moment. This is how I would be figuring it out in my exam. Just putting down on paper as much information as I can. 220 degrees. Now, an important thing to notice here is that we have a four-sided shape. Okay? So four-sided shape, we know that angles in a four-sided shape add up to 360 degrees. Okay? Four-sided shape, doesn't matter what four-sided shape it is, angles add up to 360 degrees. Just a quick note on that, you can think about a triangle's angles add up to 180. If you make another triangle, okay, they're going to be adding up to 360. Just so happens in our case, a Star Trek sign, our triangles are like that. Okay. Anyway, so they add up to 360, and we've got already 220. 220. Yep. 70. And what was this one? 15. So let's add those up, and we get 305. So that means the missing angle X we're going to get by doing 360 minus 305, which is 55 degrees. Okay. There might be quicker ways to do it, but that is how I would do it, by working it out from the start. Okay. How many marks? 3. Nice bit of algebra. So question 22. Simplify 3x squared times y to the 4, all to the power of 3. Now, to the power of 3 means that bracket is times by itself 3 times. Now, obviously, this isn't the quickest way to do it, but I'm just showing you what that notation stands for. Now, what you can actually do, because this is all multiplied, once you've expanded it out, you do not need the brackets anymore. It's just everything times together, which means you've got 3 times by itself 3 times, which happens to be 3 cubed. X squared times by itself 3 times, which happens to be x squared cubed. And y to the 4 times by itself 3 times, which happens to be y to the 4 cubed. Okay. Now, if you really wanted to go bananas, you could think, well, x squared, that's x times x, x times x, x times x, and you've got x times by itself 6 times, okay, which is x to the 6. Now, we do not actually do that because, guess what? 2 times 3 is a quick way to get the 6. So in this case, with y to the power 4, y to the power 3, we're going to do y to the power 12. 3 cubed, 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. So that is your answer, 27, x to the 6, y to the 12. So in my working out, really, with that, if I wasn't showing you, I would go straight from here to here by doing the power of 3 to each thing. Don't forget the brackets though. And then I would work out the next step as we just did. Part B, simplify. X squared minus 9 over 2x squared plus 5x minus 3. You can think of this as 2 questions in one. Question 1, question 2. For question 1, this is actually called the difference of 2 squares. Okay. You might have been taught this, you might not have seen it before, but basically it's a trick. If you have x plus a number, let's say 7, and x take away a number, say 7 again, when we actually expand this double bracket, what we get is the x squared. We get a plus 7x, but we also get a minus 7x. And then we get 7 times 7, 49, and it's a minus. This stuff in the middle, 7x minus 7x, disappears. So x squared minus 49, if you learn this trick, you can go, oh, difference of 2 squares, that's going to be x plus 7, x minus 7. So what do you notice about 9? Okay, well 9 is 3 times 3, not 7 times 7. Okay, so it's going to be, do it in green, x plus 3, x minus 3. If you do not believe me, have a go, expand it out, see what you get. Part 1 done. Part 2 is a tricky factorization question. I've done a whole video on factorizing things like this, okay, because I do an unusual trick that I think is really cool. You can check it out and see what you think for yourself. Okay, make your own choices. So, showing you what I do. I say 2 times minus 3 is minus 6. So I want 2 numbers that multiply to make minus 6 and add to get 5. So my 2 numbers are going to be minus, add to make 5, minus 6, no, plus 6 minus 1. Okay, they add to make 5, they times to make minus 6. Now my trick says, because there's a 2x squared, not just an x squared, I put a 2x bracket and a 2x bracket. I know this is going to give me actually 4x squared instead of 2x squared. So I can imagine a little half here. Okay. Now we said our 2 numbers were plus 6 minus 1. it's now time to get rid of this half, okay, by seeing if we can halve this bracket or this bracket. We're going to halve this bracket here, and we're going to get x plus 3, half everything, and the other one stays the same. So, putting in part 2, we get x plus 3, 2x minus 1. Right, on the top we're timesing by x plus 3 and x minus 3. On the bottom we're timesing by x plus 3 and 2x minus 1, which means effectively, because this is on the bottom, we're dividing by it, and we're timesing by it, we can cancel them out. So we are left with x minus 3 on the top, 2x minus 1 on the bottom. Tricky bit of algebra for you there, okay? Hope it made sense. So, question 23. Yvonne has 10 tulips bulbs in a bag. 7 of the tulip bulbs will grow into red tulips. 3 of the tulip bulbs will grow into yellow tulips. Yvonne takes a random 2 tulip bulbs from the bag. So let's draw our bag out, okay? I like a diagram. Our bag, we've got 7, 1, 2, 3, 4, 5, 6, 7 that will go to red. And I'm afraid I'm going to do these in green because yellow doesn't show up very well for you. Okay, so 3 that will grow into yellow. She takes 2 bulbs. Okay, so the first bulb, there's 7 out of 10 chance that it's going to be red. Okay, because there's 7 out of 10 in the bulb, in the bag. Okay, that means that there's a 3 out of 10 chance that it's yellow. Here's the difficult part now. Okay, let's say that we've already picked a red. That's gone. One of the reds has gone out the bag. Okay, so that means that you've only got, if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9 left. So it's out of 9. And how many reds have you got? Well, 1, 2, 3, 4, 5, 6, because you had 7 and you took 1 out. Okay, so again, when you're picking yellow, it's out of 9 again. And this time you've still got 3 of them, so it's 3 out of 9. Don't worry about simplifying on this one. You don't need to do it yet. In fact, it doesn't always help. Okay, if you went down this route, if you picked yellow first, one of these guys has gone. Okay, so we've still got 7 reds left out of 9. And we've only got 2 yellows left out of 9 to pick. Okay, so we've completed the tree diagram. Part B. Work out the probability that at least one of the bulbs will grow into a yellow tulip. At least one, that's a key word. So let's highlight the paths that we care about. Okay, we care about getting a red and then a yellow. We care about getting a yellow, then a red. We care about getting a yellow, then a yellow. Because that means in each of these you've got at least one yellow, maybe more, that doesn't matter. Now, I'm going to show you a shortcut, because the long way would be to work out the probability of each of these and add them up. Okay? Actually, I'll show you the long way, then I'll show you the shortcut. See if you notice. So, the probability of getting red then yellow, we're going along this line and we have to times 7 over 10 times 3 over 9. Okay, when you're timesing fractions, it's very easy. Times the top numbers, times the bottom numbers. 3 times 7 is 21 over 90. Okay, I've told you I'm not worrying about simplifying yet. You'll see why. Yellow then red is going to be 3 over 10 times by 7 over 9. Okay, 3 times 7 is 21. 10 times 9 is 90, the same probability as before. The other option is yellow then yellow. So 3 over 10 times 2 over 9, which is going to be 6 over 90. Now you want this, or this, or this. So it's making it more likely, and you have to add all the probabilities. Okay? Now, the reason I didn't simplify is they're all fractions out of 90. So that means that you can just add because you've got a common denominator. So 21, add 21, add 6 is going to be 48. So it's 48 over 90 is your answer. I promised you a shortcut. Now, probability of something happening and it not happening add up to 1. Okay, that's because it's certain that it's either going to happen or not happen. And all your possible options add up to 1. So let's find the probability of not at least 1. Okay, so the probability of not at least 1 is just going to be it being both red. So it's going to be 7 over 10 times 6 over 9. Okay, 7 times 6, 7 times 5, 35, add another 7, 42 over 90. Okay, now that's the probability of it not happening. We want the probability of it happening. So we're going to do 1 minus 42 over 90. 1 is 90 pieces out of 90. Okay, so you get the same answer, 48 over 90. How cool is that? Depends if you want to apply the shortcut or take longer. It's your choice, your exam. 3 marks. Question 24. It is a starred question, okay, which means there's going to be a bit of explaining. In this case, show that. OAB is a triangle. Okay, we can see that. M is the midpoint of OA. And the vector M is from O to M. Now, because it's a midpoint, this is going to be repeated here, basically. I did want to draw 2 on, but you can see it's not drawn perfectly to scale. Okay, if it was perfectly to scale, it would be the same there. Okay, anyway, ON, O to N, let's do it in a different colour, is this vector. We call it N. And we've said N is the midpoint of O to B. So that means, again, if this is drawn properly, if you double it, you get to B. It's not quite perfect there. Show that AB is parallel to MN. The vector MN, okay, is this vector from M to N. So let's think about how to get from N to N. From M to N, you need to go backwards along M and then along N. Okay? Now, if we're going backwards along a vector, it's just a negative of it. So it's minus N, and then we go plus N. Now, A to B, okay, which is the other one we're thinking about. We've done that one. Let's think how we would do that. Well, we've already said about this vector M being the same here. So we want to go backwards along M, backwards along it again. Okay? If we times that by 2, that's 2M. Now, because we're going backwards along 2M, it's going to be minus 2M. Okay, so we start off going minus 2M, and then we go along N, and we go along N again. So that's 2 lots of N. Okay. This can be factorized because there's a 2 in both. So 2, and it can be minus M plus N. Now, does that look familiar? Minus M plus N. It should do, because this thing is a vector Mn, okay, from M to N. So that means that AB is 2 times the vector Mn, like we just said. Okay. Now, if you've got any old vector and another vector is 2 times it, then it's in the same direction. Therefore, same direction, so parallel. which is what you were trying to show. Job done. Okay. Vector questions aren't that bad if you know what you're doing with them. Question 25, Certs. I've done a video on Certs. If you're not sure about this, it's an A-star topic, so it might be worth checking out the video if you're a bit unsure about them. If you are doing A-level maths, Certs is one of the first things that you're going to come across. Anyway, rationalize the denominator. This is a third, root 3 is a third. Rationalize means you do not want any thirds on the bottom of this fraction. Okay? Our trick is to times by root 3 on the bottom. So that means we have to times by root 3 on the top so as not to change what we actually started with. Because root 3 over root 3, after all, is just 1. So on the top we get 12 times root 3, which we can just write as 12 root 3. It's a bit like algebra. You'd write 12x instead of 12 times x, but it means the same thing. Root 3 times root 3. You need to know that the square root of a number times the square root of a number just gives you that number. That's the definition of a square root. What times us by itself to give you it? Now this is a fraction. We can try and simplify the fraction because we've got 12 over 3, which is 4. So the answer is 4 root 3 here. Okay, so we've got a bracket in the next part. Root 2 plus root 8, and it's squared. That means times by itself. So let's actually times it by itself. Do not even think about doing root 2 squared plus root 8 squared. That's not right. This whole bracket is being squared. From this, you've only got 2 terms. From this, you get 8 terms. 4 terms, sorry, what am I on about? I was just looking at that number 8. Okay, anyway, let's get on with this. Root 2 times root 2 is going to be 2. Root 2 times root 8, we'll do that in a minute. They're all plus, which is handy. Okay. Root 2 times root 8 again. Doesn't matter which way around you write it. Root 8, root 2, root 2, root 8. It's nice if you do it in the same way. Root 8 times root 8, for the same reason as this, is 8. So, collect like terms. 2 plus 8 is 10. Okay. Root 2, root 8, plus another root 2, root 8, is 2 lots of root 2, root 8. Root 2, root 8 can be simplified. Okay. One of your third rules, which is on the video, is it says if you've got the square root of something times the square root of something else, it's the same as the square root of those things multiplied together. You can check that on your calculator. So 2 times by 8 is 16. So that's the same as the square root of 16. Hold up, the square root of 16, we know what times us by itself to get 16. It's 4. 4 squared is 16. So that means that the square root of 16 is 4. Square and square roots are opposites. So this is actually 2 times 4. Okay? So we're going to get 10 for the first bit, plus 2 times 4, which is 8, which gives us a final answer of 18. This is a weird way to write 18, guys. Question 26. Diagram shows part of a sketch of the curve y equals sine x. Write down the coordinates of the point P. Okay, point P, you can see it here, and you need to know where that happens. Okay, you need to learn the sine graph and the cosine graph. I show all my A-level students how to remember which is which. So just before we do the question, let me show you. We split our page up into 4. I'll line up into 4. That helps us draw the graph. Okay. This green one is y equals cos x. The one that was already drawn is y equals sine x. So how do you know which is which? Because you have to remember. Well, imagine you've got a snowboarder guy, right? And he wants to have a snowboard. He's waiting at the y-axis to snowboard. He doesn't like sine x because that's uphill. He can't just simply snowboard down it. Okay? whereas he loves cos x. So you need to remember, to help you remember this, cos x is cool because you can snowboard down it. Okay, so cos x is cool, you can snowboard down cos x. Sin x isn't cool, you can't snowboard down it. So cos x, cool. Just a little tip for you. Anyway, that's not what we're doing right now. I just thought I'd mention that. Write down the coordinates of a point P. Right, this is 360 for one cycle of sine or cosine, and we're talking 360 degrees. Okay, it's going to start repeating after that the exact same thing. And you can check in your calculator if you do, say, sine of 10 degrees, you're going to get the same answer as sine of 370 degrees. It just carries on forever with that pattern. Okay. Anyway, point P. Halfway through the cycle is 180 degrees. Okay, so we've got 180 across and we've got 0 up. Okay, done. Part B, write down the coordinates of point Q. The point Q is between 180 and 360. These sections are each 90, by the way. So this is 270 degrees for x. And you need to know that sine and cosine can only go between 1 and -1. Okay, this is the very minimum, so this point is -1. Okay, let's clear that off. Here's a sketch for curve y equals a. I told you it was cos. Look, it's cool. We can snowboard down it. Okay, cos is cool. A cos of bx plus c, and x is between 0 and 360 degrees, as we can see. Find the values of a, b, and c. This is a graph transformation question, but it is a tricky one. Okay, so we start off with the graph of cos x. Okay, normal cos x. So, like I drew it up at the top, one cycle is 360 degrees, and its lowest point is at -1 here. Its highest point is at 1 here and here. It crosses through there. So let's do a quick sketch of what we started with. I have also done a transformation of graphs video, so you might want to check that out. Again, this is A star stuff, okay, so it's difficult. Now the plus C just moves the graph up, okay? So it's been moved up, and it's moved up, you can see there. The angle has been times by x, okay? So the graph has been stretched inwards. It's been pushed together, okay, which is why it's got more periods in the same amount of space. And the amount of periods that you've got, let's count up. You've got 1, 2, 3 whole periods instead of 1, okay? So it's been stretched in by a third, scale factor of a third, which means that we do to the x, we times by 3. We do the opposite when it's inside to x. So that's the x one done. The others are to y, okay, outside the bracket. So we're outside our f of x, and we are timesing by a. So we want to times by a number to make it bigger. Now, can you see that it goes from -1 to 3? Before it went 2 here, now it's going 4 here. Okay, so it's been doubled, it's been times by 2, and when you're doing it to y, you just do the same thing. And finally, as well as being times by 2, it has it moved up, or have I just drawn it dodgy? No, it has moved up, because if we think before, it would be there, okay, with this being the center of the graph. It's moved up 1. Okay, and we know that because it has to have 2 either side. Okay, so it's plus 1. moved up one. So our A value is 2, our B value is 3, our C value is 1. I think that was quite a tricky one to do at the end. I'm apologising that I didn't explain that last one probably as well as I should have done, but that is kind of moving on to A level there. Okay. If you check out the transformation of graphs video, that one will become clearer, I hope. Right, we've done the non-calculated paper there. I hope that it helped you. I hope it's going to help you achieve maths. Good luck in your revision, and wish you all the best for the exams. Thanks for watching.